deduction. The concept of deduction, we have two things. One is by using Fourier inversion formula. Say, suppose if you take this problem, here we have two deduced part. The first one is sin t by t model, The second part is sin t by t the whole square model, So the first case what we saw is, this is the answer for us. By solving the Fourier transform of f of x equal to 1, we are getting the result as 2 by root 2 by sin SA by S. So if I am using Fourier inversion formula, I can simplify this and I can get the result as sin t by t integral 0 to t dt is equal to pi by 2. The reason behind this, I don't have any square terms here. This is just sin SA by S. So by solving this, I can get the reduced part by using the inversion formula as sin t by t dt equal to pi by 2. But if you see the second reduced part, case, it is sin t by t whole square. Alright, you can see what you have done. The second case, it is sin t by t whole square dt equal to some answer. So how will I extend the sin t by t to sin t by t whole square model? So how that extension can happen? So for that case, we are using the next concept called Parseval's identity. This is the next level concept we are using in reduced part, because the reason is we have to double the concept. We have to expand the given function to the next level. So double level. Likewise, in other problems also. Maybe 1 minus mod x, there are two reduced parts. In one it is sin t by t whole square. The next one is sin t by t whole power 4. So you are going to double the expansion, that is double the function. We are going to use Parseval's identity wherever there is a need of doubling that kind of idea. So that is, here I am having sin t by t concept for, I am getting the result of sin t by t for Fourier inversion. Now I am going to expand it to square terms. I am using Parseval's identity. What is the formula first of all? Parseval's formula. So it is integral. On both sides we have integration, minus into plus infinity. In the left side it is mod f of x square dx is equal to integral minus into plus infinity. Here Fourier transform. That is Fourier of f of x square dx. So one side, actually this is Fourier, so here it is ds. So in one side you are going to integrate the question, that is function given. You are going to substitute what is f of x, you have to square and you have to integrate. In the other side, already you have found what is your Fourier for that function. That answer you have to substitute, you have to square, then you have to integrate. So two things at the stage you are going to work on. Okay, I am repeating again. This is the Parseval's identity. Formula or expansion. So here the left side I will have substitute f of x, that is the given function in the question. Here it is 1. In the other side, there is a right hand side, Fourier transform of f of x. So the answer what I got in Fourier transform, I will apply that. Then I will expand the series. So here, so let us take the left hand side. So suppose if you are going to take the left hand side, it is integral minus into plus infinity mod f of x square dx, that is equal to integral. So what is the function given in the question? The function given in the question is f of x is equal to 1. Am I right? F of x is equal to 1. That I will apply. So here f of x is 1. So 1 square dx. Because it is square, so 1 square dx. So what is the limit for f of x? In the question, what is the limit given? That is minus a to plus a. Now you have to integrate this. So if you integrate 1 again, it is 1. So integration of dx is x. So integration of dx is x here. The limit is minus a to plus a. So a, that is upper limit, minus of lower limit. So minus plus, so 2a. Alright. So your left hand side is 2a now. That is what is written there. Your left hand side, if you integrate 1 with the limit minus a to plus a, you will get the answer as 2a. That you can substitute in the left side. Alright? You can substitute in the left side. Very clear. You know the formula. You can know if you know how to integrate. Then you substitute in the place of left side. So in the right side again. So in the right side, what you do? You substitute what you got for the Fourier transform. So 2 by root 2 by sin SA by S. So what you do, you substitute there and you square it. After squaring, you get this answer. What you do is just you take all the constant terms to other side. All the constant terms to other side. So that you get integral minus 2 plus b sin as by s whole square ds is equal to a pi. So this is the term what you get after substituting on both sides. So from here, you have to check what is the answer to be brought out. What is the deduced result? What is the deduced result?
Sin 0 to infinity sin t by t
whole square dt is equal to again pi by 2. Am I right? So that is what we have got here. So this result I want. Am I right? This result I want. So here, what is missing? The final answer a is missing. So what we have done, we have to substitute what is a here. So I think when you bring this a to the other side, so it becomes, what happens here? So here you have this term, it comes as it is in the trivial function. So you will write twice 0 to a sin t by t dt. This a and this a, what happens here? I think it cancels each other. What happens there? Can you understand what I am asking? Here this a and this a gets cancelled. Here you have a term. You see what happens to this. So sin t by t whole square dt equal to. So here you have 2. The 2 if it comes to the other side, it's sin by 2. That is pi by 2. You get the result. So